Hello, welcome to Unit 2, Lesson 19, Solutions to Inequalities in One Variables. Today's learning objectives are to be able to graph the solution to an inequality in one variable, to solve one variable inequalities and interpret the solutions in terms of the situation, and understand that the solution to an inequality can be a range of values that make the inequality true. Let's go ahead and take a look at the first activity. For this activity, it wants you to first write some solutions for the inequalities y is less than or equal to 9.2, and then write one solution for the inequality 7 times the difference of 3 and x is greater than 14. So go ahead, pause the video, and work on those two questions. For question 1, basically you're looking at any number that is either equal to 9.2 or less than. So some possible solutions are 9.2, 8, 4.5, and even -7. Obviously, you don't have to be exact with mine, but the key thing I want to point out here is that 9.2 is part of that solution set. Question 2, again, you have a variety of answers, so you could have 0.5, you could have 0, -1, -6. Now, how you came about this is, maybe you just substituted in different numbers until you got what works. The key thing I want to point out here is that any number that you should choose should all be to the left of +1. So if this was a number line and that was +1, we're talking about everything over here. 1 is kind of that boundary point. These numbers that are all less than 1 are called the solution set to the inequality. With inequalities, it's not just one solution, we have a set of solutions. So any number that makes this inequality true would be part of that solution set. Now, this is connected to the equation version of this. If we were to write this as the equation, we know that in our equation version, x is equal to 1 if we were to solve that. So that's kind of connected to our inequality because here we're saying all of our solutions are less than 1. Now, another reason why we know that the solution set is the numbers less than 1 is because in order for this to be exactly equal to 2, we know that we need to do 7 times 2. In order for 3 minus x to be equal to 2, we know x has to be equal to 1. So therefore, in order to meet the constraint that is greater than 1, we really want this number 2 to be bigger than 2. We don't want it to be exactly 2. We actually want it to be bigger than 2. And the only way to make this bigger than 2 is if we take smaller numbers. So therefore, x has to be less than 1. So as you're thinking about the inequality, think about how can I make this a true statement, just kind of working through each part. So again, we know 2 has to be bigger in order for to be bigger than our constraint of 14, right? 7 times 3 is 21. The only way we would get 7 times 3 was if we did 3 minus 0. So notice right away we're already choosing a smaller number than 1. If we did 3 minus -1, that's equal to 4. So 7 times 4 is 28. So again, we're bigger than 14. So that's how we come up with this idea of being less than 1. One way to show all the entire solution set for an inequality is to write that actual final inequality, x is less than 1. But we could also draw it on a number line. So if 1 is here, and I create my number line around it, I know I want all the numbers less than 1. So I know I'm going to be going this way. And then 1, is going to be our boundary point. So I'm going to have an open circle on the 1. If you recall, or if you remember from when you did inequalities, I'm not sure the last time you did inequalities, but if you recall with the boundary points, If an open circle is on the boundary point, we're saying that it's not part of the solution set. It's kind of just hovering there, so we know where the boundary lies. If it was a closed circle, then we would say it is part of the solution set. Let's go ahead and take a look at activity 2. So for activity 2, it says the teacher's choosing 2 options for a class trip to an orchard. Orchard A, admission costs $9 per person and 3 chaperones are required. At Orchard B, the cost is $10 per person, but only 1 chaperone is required. At each orchard, the same price applies to both chaperones and students. There's 2 questions. Question 1 has an A, B, and C. Question 2 continues on to the next page, and that has an A, B, C, and D. So go ahead, pause the video, and try to work through these questions. All right, so question A, which orchard would be cheaper to visit if the class had 8 students, 12 students, or 30 students? So with orchard, with 8 students, if I was to go to Orchard A, I would have to pay first the 3 times 9 for the chaperones, plus 8 times 9, which is essentially just 9 times 8 plus 3, which is just 9 times 11, which is 99. For Orchard B, I would do 10 times 1 first for my, times 1, that's my chaperone, plus the 10 times 8, which again is essentially 10 times 8 plus 1, which is 10 times 9, which is $90. So we know in this case Orchard B is better. I can repeat that process for B. So I'm going to do 9 times 12 plus 3. 9, which is essentially 9 times 15, which is $135. For Orchard B, I'm doing 10 times 12 plus 1, which is 10 times 13, which is $130. So again, Orchard B is going to be cheaper for this one. And for the last one, Orchard A, I'm doing 9 times, I'm just going to say 33, skip a step. So 9 times 33 is 297, and then B is 10 times 31, which is $310. So here we can see that Orchard A is going to be the better option. For question 2, it says to help compare the cost of her 2 options, the teacher first writes the equation 9 times n plus 3 equals 10 times n plus 1, and then she writes the inequality. 9 times n plus 3 is less than 10 times n plus 1. Question A asks, what does n represent in each statement? So in this case, we are talking about the number of students on the field trip. So number of students on, field trip. For B, in this situation, what does the equation represent, or what does it mean? So this equation is, we're asking when is the cost of Orchard A going to be equal to the cost of Orchard B? So, when will the cost of Orchard A be equal to the cost of Orchard B? And similarly, the equation is asking us when will the cost of Orchard A be less than the cost of Orchard B? The last question asks you to graph the solution to the inequality over the number line and to be sure to show your reasoning or explain your reasoning. So there are a couple of different ways that you could present this. One way is just plugging in different values of n until the inequality is no longer true. Another way would be to solve the equation first, and that would find your boundary point. And then from there, trying to figure out if the lower or the higher numbers would make the inequality true. The other way is to reason out the differences in the cost per student and cost for chaperone. I'm going to go ahead and show you the equation way because that's kind of where we're heading with this. So 9 times n plus 3 equals 10 times n plus 1. So I have 9n plus 27 equals 10n plus 10. I'm going to get my variables on one side. So 27 equals n plus 10 minus 10 minus 10. So n is equal to 17. So this number tells me that when 17 students go, it will cost the same at either orchard. So again, this is going to be my boundary point. The next thing I need to do, though, is figure out what part of the, or which side my solution set is going to go. And to do that, I'm just going to choose a number on either side and plug it in. So I typically go with 0 because 0 is a pretty easy number to test. And I am testing this side because 0 falls to the left of 17. So let's plug 0 in and see what happens. So n is 0 plus 3. Is that going to be equal to 10 times, or sorry, not equal. Is that going to be less than 10 times 0 plus 1? So essentially I'm doing 9 times 3, which is 27, and 10 times 1, which is 10. So I can see that this is a false statement, which tells me I don't want this side of the number line. Instead, I want the other side of the number line. So when I graph it, I'm actually going to go to the right. So let's skip. So 19, 21, 23, 25. I'm going to go the other way too, just because it's a good idea to have both sides filled out. Okay. Again, I'm using an open circle for my boundary point because 17 is not part of the solution set. So I'm saying 17 is not a possible solution, but I do need to hover the circle there so that it is a true, so that we know where the line goes to. The other thing I need to do is write my inequality because, again, although writing it as a number line is one way to express it, it's another way to express it is as a inequality. So you can write that as either n is greater than 17 because we can see we want the values of 17, we want the values greater than 17, or you could write 17 is less than n because, again, 17 is not, is going to be less than what my values of n are. All right, let's move on to activity 3. So for this next activity, it says to help pay for tuition, a college student plans to work in the evenings and on the weekends. He has been offered 2 part-time jobs working in the guest services department at a hotel and waiting tables at a popular restaurant. The job at the hotel pays $18 an hour and offers $33 in transportation allowance per month. The job at the restaurant pays $7.50 an hour plus tips. The entire waitstaff typically collects about $50 in tips each hour. Tips are divided equally among the 4 waitstaff members who share the shift. The equation, 750h plus 50 divided by 4h, is equal to 18h plus 33, represents a possible constraint about the situation. So what you need to do is answer questions 1, 2, and 3. They do continue on to the next page, so go ahead, pause the video, and do that. All right, let's take a look at the first question. So it says to solve the equation and check your solution. So 750h plus 50 over 4h equals 18h plus 33. So first thing I'm going to do is combine my like terms. So 7.50 plus 50 over 4 is equal to 20. So I have 20h is equal to 18h plus 33. Then I need to get my variables on one side. So I'm going to subtract 18h from both sides. So now I have 2h is equal to 33. And then I'm going to divide both sides by by 2. And I get h is equal to 16.5. So that tells us when they work, when the college student works 16.5 hours, they'll make the same amount at either job. From here, it wants us to put the scale on the number line that would represent, put the scale on the number line so that the point marked with the circle represents the solution. So if this one is 16.5, then what I could do over here is 16, this is 17. Then we have skip 1, that's 18, skip 1, that's 20, go backwards, that's 15 and 14. So I'm going up by half increments. All right, so question 2 asks if the student works less than 16.5 hours, is one going to be better than the other? And the same thing for if it's more than 16.5 hours. So let's do the less than first. So again, you're just choosing any number that falls to the left of the boundary point. I like to work with 0 a lot because it does make it easier to plug into. So I'm just going to take 0 and plug it in for h. So I end up with $0 for the first job, which had the tips, and then the other one is $33, and that's the one with the transportation per month. So obviously, in this case, the job with the hotel pay is going to be the better options because you're always going to get that $33 regardless of the number of hours you work, and that's going to help pay you more than the amount of tips you would make. So I probably should erase this equal sign because it's not really an equal sign, it's a less than sign. All right, so now let's see if we go the other direction. If we choose a number greater than the boundary point, what happens? So I'm going to go with 20. So I have 7.50 times 20 plus 50 over 4 times 20 equals 18 times 20. Actually, we don't know if it equals, plus 33. Okay, so when I do the math for that, 750 times 20 is 150. 50 divided by 4 times 20 is 250. So we can see at the restaurant job that they are going to make $400, whereas at the hotel job, 18 times 20 is 360. And then when we add that 33, we get 393. So we see in this case it flip-flops. The restaurant pays more. So it becomes a point where those tips start to pay more because of the number of hours you're working. All right, question 3 says here's 2 inequalities and 2 graphs that represent the solutions to the inequalities. It says put the same scale on each number line so the circle represents the number of hours. So we're just going to go with that same scale that we've used before. 17, 18. And I'm going to put that on both of them because the scale doesn't change. 17, 18. And then it says match the inequality with the graph that shows its solution. So this first inequality is talking about when the hotel pays more. And the second one talks about when the restaurant pays more. So if we look back at our previous response, we said when we were smaller than the boundary point, the hotel job was going to pay more. So it makes sense that graph B goes with inequality 1. And we found that with the hotel job, that was when the solution set was greater than the boundary point. So that makes sense that graph A goes with inequality 2. So in general, we're comparing the pay rates for each hotel, or the hotel and the restaurant. We could simplify the restaurant to just be 20H, right? Which we kind of did right here. So we're comparing $20 an hour versus $18 an hour. And where it gets a little tricky is that this hotel also has that $33. So initially that $33 has more of an impact on the amount of money they bring home when they're not working as many hours. But the more hours you work, the farther those two rates really impact each other. And we see that it really makes more sense to work at the restaurant. The key thing to take away from this activity, though, is that you really want to focus on where your solution set is in order to graph the to connect the graph. So when we're talking about the inequality 1, right, the greater side is that hotel pay, and that was only greater when they worked less than the boundary point. When we looked at the second inequality, we wanted the restaurant pay to be more, and that only happened when we looked at the solution set that was greater than the boundary point. So doing that check is really super important to help you determine which way to go. All right, let's go ahead and move on to the last activity. So for this activity, you do have to solve some different inequalities and then graph them. So let's do this one together for time's sake. So the first inequality we have to solve, the first equation we have to solve is this. So the first thing I am going to do is I am going to get rid of that 5, and I do that by multiplying both sides by 5. And when I multiply both sides by 5, I have to remember I'm multiplying everything. On the left side, I'm just multiplying by a reciprocal, so the 5's cancel out, and I'm left with -4 times x plus 3. On the right side, though, I have to do 4 times 5, which is 20. And I also have to do 12 times 5, which is 60. Okay, from here, I have a couple of options. I could distribute the -4, or I could divide it out to get rid of it. So I'm going to go ahead and divide it out because it's less steps. So now I have x plus 3 equals -5x plus 15. From here, I'm going to get my variables on one side. So now I'm at 6x plus 3 equals 15. Isolate x, so subtract 3 from both sides. 6x equals 12, divide by 6, and x equals 2. So the solution to this equation is 2. Let's go to the next page. Now we're turning it into an inequality. So it says choose a couple values less than 2 for x. So x equals 2, that's our boundary point. I'm going to choose a couple values less than 2. Let's go with 0, my favorite, and then let's start with 0. So we have -4 times 0 plus 3 over 5 less than or equal to 4 times 0 minus 12. 0 plus 3 is 3. Negative 4 times 3 is negative 12. Negative 12 divided by 5 is negative 2.4. 4 times 0 is 0, and then we have negative, 0 minus negative 12, 0 minus 12 is negative 12. So in this case, is this a true statement? Negative 2.4 is less than or equal to negative 12. No, this is false. Let's choose one other number less than 2. Let's go with 1. So we have negative 4 times 1 plus 3 all over 5. And we're seeing if that's less than or equal to 4 times 1 minus 12. 1 plus 3 is 4. Negative 4 times 4 is negative 16. Negative 16 divided by 5 is negative 3.2. 4 times 1 is 4. 4 minus 12 is negative 8. So again, we're checking, is negative 3.2 less than or equal to negative 8? And again, we can see this is a false statement. So therefore, neither of these would be solutions to the inequality. Now, let's check numbers greater than 2. So let's just go ahead and do 3. We have 3 plus 3 is 5. All over 5 is less than or equal to 4 times 3 minus 12. 3 plus 3 is 6. 4 times 6 is 24. 24 divided by 5, negative 24, divided by 5 is negative 4.8. And then 4 times 3 is 12. 12 minus 12 is 0. In this case, yes, this is a true statement, so that's good. We'll do one more. We'll do 4. So this time we're doing, 4 plus 3 all over 5 is less than or equal to 4 times 4 minus 12. So 4 plus 3 is 7. 4 times 7 is 28. So that's negative 28. 28 divided by 5 is 5.6. So we have negative 5.6. 4 times 4 is 16. 16 minus 12 is 4. So negative 5.6 is less than 4, which again is a true statement. So for these, we would say, yes, these are possible solutions to the inequality. For the next question, it says, choose 2, and is that a possible solution? So now I'm going to plug 2 in. So negative 4, 2 plus 3 over 5, 4 times 2 minus 12. 2 plus 3 is 5. Negative 4 times 5 is negative 20. Negative 20 divided by 5 is negative 4. 4 times 2 is 8. 8 minus 12 is also negative 4. And again, this is a true statement because negative 4 is less than or equal to negative 4. Nothing has changed. So this one is also a solution. Last question asked us to graph that. So my boundary point is positive 2, so I'm going to have a circle there. Because 2 is part of the solution set, I want it to be a closed circle so that it's grabbing onto that boundary point. And I also determined that the numbers to the right of the boundary point are the true statement, so I'm going to draw my arrow that way. So the key thing to remember with solving inequalities is that you determine which way to draw your line based on where the solution set falls. And you need to do a solution test to determine that. Don't just base it off which way the arrow is going, because you can see here our arrow for this one was technically pointing to the left, but we drew to the right. So it's not going to be just the direction in which the arrow is pointing. You have to think about where the solution set falls. So doing that solution test will help you. Also, another key thing to remember is that we use a closed circle when we want to include the boundary point as part of the solution. So boundary point is solution, is part of solution set. And we also want to use an open circle when the boundary point, you guessed it, is not part of the solution set. All right, well, that is it for this lesson. Make sure you submit it so you can get your participation points and you can get started on your cool down. Thanks for watching.